Since we didn't have time to review before your first lab practical due to inclement weather last week, I'm recording a series of short videos that you can use to help you review for the lab practical if you like. We're going to talk first about lab safety and Lab 1. Lab safety, you have a handout on page 5 that deals with various aspects of lab safety, things like not wearing contact lenses in the lab, always be sure you wear goggles, don't drink or eat or smoke in the lab, apply makeup, always put chemicals back in their correct spot, but do not pour chemicals back into the containers unless that you've been instructed to do so. Note the location of safety equipment. Be sure that you have on the correct clothing. Don't handle hot glassware. Be careful. Be sure you read the labels always. Put the tops back on. That's what they mean by stoppering all reagent bottles when not in use. We do have gloves available. We have goggles available for those of you who do not have them. If something should happen in the lab, you should always notify the teacher immediately. You should report all accidents, and if you need any type of first aid, be sure to notify the teacher about that as soon as possible. So those are some of our lab safety rules that we talked about. You'll have 2 or 3 lab safety questions on your first lab practical. In addition to lab safety, you will have a few questions, probably 2 or 3 questions about Lab 1. Lab 1 starts on page 9 in your lab manual, and it deals with the scientific method. We didn't talk about anything on page 9, but we did talk about some material on pages 10 and 11. So starting on page 10, one of the things I would recommend that you know would be the steps of the scientific method in order. We start with making observations. Those could be visual, they could be auditory, they could be tactile, they could be observing a type of organism. So we have lots of different types of observations that we might make. Then we talked about the fact that you take those observations and formulate a hypothesis, which is a tentative decision about the outcome of your experiment that you plan to make. The test of your hypothesis is your experiment. We always want to make sure that we have a controlled experiment. We want to include at least a negative control so that we can see if our test procedure is set up correctly. Because if our negative control reacts, we know that we have probably made a mistake. There's some kind of flaw in our experimental design. Once we have finished our experiment, we are going to collect data during the course of that experiment, and then we're going to analyze that data. We're going to use it to come to a conclusion as to whether or not our data support or do not support the hypothesis. We never say a hypothesis is true because we know that we can have future experiments that might nullify some or part of all of our observations. The conclusion, once we've developed that, we're going to go back, we're going to repeat our experiment multiple times. One time is not enough. We should have people all over the world testing our hypothesis under various conditions to see if our hypothesis is still showing us the same conclusion over and over again. If after many years and many experiments, our conclusion does show us that we are on the right track, then that conclusion might lead us to develop a theory. Once our hypothesis has been shown to be supported over and over again, perhaps we'll have a theory. When we look at the flow chart in figure 1.2, we can see the hypothesis leads to the experiment and the data lead us to a conclusion. We can see that we can repeat that particular part of the scientific method over and over again. Only occasionally do we actually go from conclusion to scientific theory. So that's an overview of what we talked about with the scientific method.